Hi, today I'm going to be presenting the Runtime Terror engine, which is a game engine that we created for as a final project for our building game engines class. And this is a small hierarchy of our current game engine C++ API. So as you can see, we are basically relying on the component system and the game object to handle most of the heavyweight lifting. And then we have some classes that are pertaining to rendering or physics per se, and then some classes for sound and so on and so forth. So in this project we mainly focused on our API and the ease of use. So we wanted the users who are using our game engine to be able to create any kind of game, 2D game they want with our engine. And we strived so that the API structure is really easy to use and the user doesn't have to any of the heavyweight lifting that is required in general with games. So uh, yeah, so this uh, this is our code base, and before we begin diving into code, I'll just quickly demo our game engine. The libraries are already built, so this should work. As you can see, this is our main UI for our game engine. We have a dedicated tile editor, and we can create game objects from here. So building a game would take a lot of time, so we already built a few which we are going to be showcasing. And yeah, first one we want to demo is Pong. So we open the config file. This config file is generated when you create a game using our game engine's editor UI. So we load it, and right now the preview is just for previewing where the relative positions of the objects are. Like these are the 4 enemies. It's just so that you can preview them, and you can put X and Y. Once you determine that you are fine with X and Y, all you have to do is go to enemy, and you can update their properties from here and here, right? Okay, so I'll just hit run, and this is our Pac-Man game. So as you can see, we can move, right? We also have the ability to pause the game, and then game over. Yeah, we didn't implement any restart functionality because this was really a test for our game engine and nothing more. So yeah, another game that we did try to implement was Pong. I'm gonna quickly demo that as well. This is the Pong's config file. Pin it, paste it, load it, right, and I hit run, and this is the Pong game. As you can see, 2 players can play, right? So this was just a test for our game engine, and yeah, so this is it. From the purposes of tile editor, we couldn't integrate tile editor in the preview window, so we created a dedicated one for that in C++. So our tile editor is also completely based on C++. So for our tile editor, let's use this file. So it's asking for a BMP image. We also have support for PNG images. We'll demo it with BMP, right? So I select BMP here. Now these are this tile editor only supports equal size tiles in a BMP folder. So yeah, this is the destination width and height, update config, and now here I can type in the tile map editor, and it will start rendering. But let's just load a tile map since we already have one. I think it's called level1.txt. Okay, I think the images size were wrong. It was 16 and 16. (32) and 32, right? I'll update the config and load tile map. So it looks something like this. Okay. Now that we have our game engine UI done, we can dive into the code. So from the code point of view, what we really strived for was that the user will only ever create game objects. So all the files that you see here are simply game objects, and the user just provides the logic on how this game object should act. All the necessary organization and orchestration is actually taken care by the C++ API. We have this game runner class which is actually responsible for reading from these Python files and generating objects, like this method generates object from that config file and puts in the game loop, and this class basically does all the heavy lifting. So all we really have to worry about as users of this game engine is um, providing the logic for a particular game object. So for instance, you notice that in our Pac-Man game we had four enemies, right? So each of the enemies actually configured like this. So this is the same class that is used for all four, but we modify their properties based on the configuration, basically the object ID that we set. So if you look back at here and open, right, so enemy 1, right, enemy 2, so they have different positions and velocities, and based on these IDs we are assigning them different sprites here. So that is how we handle the game objects. The other really important thing with our game engine was that we used box 2D for collision and physics. So that really simplified our process, and we tried to provide a clean API to do so, because box 2D is somewhat difficult to use and understand. For instance, uh, a simple code to create physics body is this big, and it creates a lot of uh, B2 body instances and any other things that you might add to it, and so it becomes really difficult for the user to keep track of them. So we don't provide the user access to this physics manager, and it is completely internal to the C++ API. So all the user really needs to do to create physics bodies is just attach a physics component to it. That makes the task really easy. For instance, in enemy, we configured this physics component here, right, using this config, and then we simply added it. And once we do add it, the game object class, all of these classes extend from game object, and so the game object class has callbacks called processes collision start and process collision end, and they provide you they pass along with them the ID of the object that collided with the current object. So let's say we collided with another object whose ID starts with or has enemy in it. So we just call this collide with enemy function, which is this. So this is different logic. But if you collide with player, you play this sound effect, and you call the game over method on that on the game state manager. So this is how we find the game object. So once you figure out which object it is, you just need to find it and call appropriate method on it. So that's how we simplified our process. And yeah, and game state manager is another important thing. Like, this is also another normal game object. This was really a test for our game engine, because if you need some sort of orchestration which is like throughout the game, because all these objects are really just representing one entity on the game, but what if you need something to handle throughout the game? For instance, in the Pac-Man we saw that there was game over and game end. So for instance, if I run and I can pause, so I need something to pause the entire game, right? Similarly, if the game over is, there is one object that needs to know that game is over or all the dots are empty. So in order to do that, we have certain callbacks from our API. For instance, on pause and on resume, these are also implemented in the game objects core. And basically, whenever the user presses pause, uh, this this method gets triggered, and when the game is unpaused, this method gets triggered. So yeah, in order to pause, what we really did was we called a pause game method on the game runner. So this only works if you call if you pause the game using this method. if you use your custom logic, these callbacks won't be called. So yeah, that's pretty much it for our API and game engine, and thank you so much for watching.